Hey everyone, welcome back to the channel. In this video, we're going to talk about optimistic locking in JPA. Alright, so what exactly is optimistic locking? In simple words, optimistic locking allows multiple users or transactions to read and work with the same data at the same time, without locking the row immediately. It assumes things will go fine, that's why it's called optimistic. But when someone tries to update the data, it checks if the data has changed in the meantime. If the version doesn't match, then it throws an error, and your update fails. This way, it helps avoid conflicts, without using heavy database locks like we saw in pessimistic locking. Now let's see how to implement it in code. Alright, one important thing you should know: optimistic locking requires a version field in your entity. This is how JPA keeps track of whether the data has been changed by someone else in between. So if your entity doesn't have a @version field, and you try to use lock mode type.optimistic, JPA will throw an error immediately. Let's implement optimistic locking now. Just copy one of our existing find_by_id methods from the repository, the one where we passed a lock type, and we'll change the lock mode to optimistic. Alright, our optimistic locking method is ready, and now let's add one more method to test a real update scenario. We're going to write an update student method, so follow along with me. Awesome, the repository method is ready. Now let's create a new API to call this. Follow along with me step by step. We're going to add this inside our lock demo controller. Take the full student object in the request body. Call our find_by_id with optimistic lock method, the one we created earlier with lock mode type.optimistic. Alright, now let's set the student name on our student object from request. And call the update student. Now let's start the application to see it in action. See, right now in my student table, the row with student_ID1 has student_name Pankaj and version 3. Okay, let's call our new update API and see how optimistic locking behaves. Awesome, we got the success response, and if you look closely, the version has gone from 3 to 4 automatically. Let's switch over to dbeaver and run a quick select to confirm. See that? Student_name is now Shubham and version is 4. That's optimistic locking in action, automatic version bump on update, with no conflicts. Check this out. Look at the SQL JPA just ran for our update. See how JPA automatically included the version field both in the set clause and in the where clause. Alright, now comes the fun part. Let's see a real-time version conflict with optimistic locking. Okay, let's jump back into the controller and uncomment that thread.sleep. Let's update our pause duration. Change it from 120 seconds to 30 seconds. Let's start the application. See right now in the database, the version for student_ID1 is 4. As soon as our API reads the student data from the database and starts waiting for 30 seconds because of thread.sleep. At that exact moment, we'll go to dbeaver and try to update the same record. We'll manually set the version to 5. Now let's hit the API. Alright, now quickly switch to dbeaver and run an update query to manually set the version to 5. Alright, it's done. We've manually set the version to 5 from dbeaver. Now let's wait for the remaining few seconds. Remember, our API still has the old version 4 loaded in memory when it started the transaction. So when the 30 seconds are over and it tries to commit the update, JPA will compare versions. And since the version in DB is already 5, but JPA thinks it's still 4, it will throw an optimistic lock exception. Let's wait and watch it. See? We got an error, just like expected. Check the console logs. It says something like optimistic lock exception, or maybe even something like row was updated or deleted by another transaction. That's JPA telling us, hey, the version you're trying to update is old. Someone else already modified this row. This is exactly how optimistic locking protects our data from being overwritten in concurrent environments. Pretty cool, right? And we didn't write any manual version check. JPA handled it all for us. Now let's take it one step further. Time to look at optimistic_force_increment. Optimistic_force_increment not only checks the version like regular optimistic locking, it also increments the version even if you're just reading the data. This is super useful when you want to signal that something happened to the data, like a read with side effects, or when you just want to notify other transactions that something has changed. Alright, let's implement it. Follow along with me. Just copy one of our existing findById methods and change the lock mode to optimistic_force_increment. Alright, now let's call this new method from the first API we created in the previous video. Now let's start the application. See? The current version is now 5. Alright, now let's hit this API. See that? Now the version is 6. Let's verify it from the database. Run a quick select in dbeaver. And yep, confirmed. The version has been bumped to 6. Now check the console logs. Even though we didn't update or change anything, JPA still fired an update query behind the scenes. That's what optimistic_force_increment does. It tells Hibernate, hey, I touched this row, so go ahead and bump the version anyway. Pretty powerful when you want to track read-based changes, trigger downstream effects, or force version sync. And here's one more very important thing you need to know. If someone changes the version in between, let's say while the transaction is open, maybe another API or even a manual DB update changes the row. Then when our transaction finally tries to commit, JPA will throw an optimistic lock exception. Why? Because JPA compares the version it originally read with the current version in the database, and if it's different, it refuses to proceed. That's how it avoids overwriting someone else's changes. So remember, even with optimistic_force_increment, if someone sneaks in and changes the version while you're holding the transaction, your update fails. And that's exactly the kind of conflict optimistic locking is designed to protect against. Alright guys, quick summary of what we did in this video. We explored optimistic locking, where JPA checks the version field when committing the transaction. Then we move to optimistic_force_increment, which not only checks the version, it actually bumps the version even if we're just reading. We saw how JPA automatically throws an exception if someone changes the version in between, and that's how it prevents data conflicts in high concurrency environments. In the next video, we'll learn how to delete records properly using Entity Manager, with clean and safe code. So if you're enjoying this series, don't forget to like, comment, subscribe, and hit the notification bell. It really helps and keeps you updated. Alright, see you in the next one.